Hi guys, welcome to NeuRes Day 5. We'll be starting the session shortly within a few minutes. Okay, so hi guys, welcome to NeuRes Day 5. Today's topic will be natural language processing. So if you have kept up to date with us, we discovered convolutional networks, the basics to data science and machine learning. And today we'll be focusing on NLP, which is like a very well-known and wide domain and a lot of focus nowadays. So today the session will be chaired by Rohan Mathur. He's a ML developer here at TS Community, and Akshat Anand. He's a project's lead here. So the session will start off with Rohan giving out his talk on natural language processing. We'll go through some theory, some basic code and everything, and it'll be super interesting. If any doubts, you could always ask in the chat box.
All right, thanks, Soumya. So yeah, let's start. Let me just confirm if you guys can see my screen. Just give a heads up on the chat or you can react. All right, I think it's great. Fine. So, okay, let's start. So as Soumya said, today's webinar is on NLP, and great to have you all present here with us. And yeah, let's start. So today's speakers are me, Rohan Mathur, and alongside with me is Akshat here. So Akshat.
Thanks, Rohan, for the great intro. Also, the Soumya. So, for the today's meet, we are having topics that is divided into two parts. Rohan will be covering in that is what is NLP, why NLP, how NLP pipeline works, followed by text processing, counting words, feature extractions, modeling, and by me, part of speech tagging, entity recognition, bag of words, TF-IDF, and the evaluation matrix, COSINE similarity, and JACCARD similarity. So Rohan, take the stage and move on.
So yeah, thanks Akshat. So obviously before we start, the first question that pops up into our mind is why NLP, right? What is NLP? Where is it used? How is it used? And why is it one of the most sought after skills in the tech industry? So let's explore. So firstly, what does NLP stand for? NLP stands for natural language processing. Natural means anything that exists in nature, and language means anything like we have English is a language, Hindi is a language. So basically, it's a mode of communication. And if you've been following our previous webinars, you might have an idea or understanding what processing is. So it's basically performing something and converting something to bring about change. So we've seen what NLP, like we've seen an overview of what NLP is, but let's look at some use cases where NLP is used. I'll be discussing a few of the topics and use cases where it's actually used in the modern day life. So first one here is obviously voice assistants. So everyone has an Android, everyone has a Siri, and you are all aware of what Google Assistant is. You're all aware of what Siris are. So what do? You ask them questions, right? You ask them questions and they respond. So there are questions like you can ask what time is the bus from this city, which classes do I have today, when will college reopen? Although that's not a question that I think a voice assistant can answer. But yeah, so that's an example. Who is Donald Knuth? So these are some certain questions you can ask your voice assistants. So fun fact, Donald Knuth is the father of algorithms and analysis. Another example of NLP where it's used is information extraction. So information extraction allows you to extract the important stuff from your raw data. So let's say I have an example of an email, and the email has certain stuff like we have decided, like in this example that I've taken here, we have decided to meet tomorrow at 10 a.m. in the lab. So if I want to find out the keywords and find out what the meaning is, information extraction extracts this info and condenses our data into something more concise. So we have here a to-do list, which is the meeting time. It gives out the date and also the venue. So that's how information action works. Next is sentiment analysis. So if you're looking at this word, you might have a basic idea what sentiment analysis does. Analysis of sentiments, right? So if you want to find out sentiments of a particular word, sentiments can be either positive, they can be negative, or they can be neutral. So that, and NLP is a major part of the role play behind sentiment analysis. So I'll be discussing few examples where it's used. Let's say you have Flipkart, you have Amazon, right? There are products that are sold there. Now, each product, when you always scroll down, you have product reviews, right? Product reviews. Now, these can be either good, where, as you can see, example is here, cool product, excellent, I like it. So what are these? These are positive sentiments about a particular product. And if people don't like it, they can just mention it's I don't like it, or this particular thing was bad, give a analysis of what was there. So NLP helps you actually find out sentences and extract sentences and find out if they are negative or positive or not. There are also means where you can take this one step further. You can actually find out steps and other sentiments like anger, like desperation, emotion. So these are steps which you can even perform after you perform this finding out the basics, which is the positive, negative, and neutral. Next is machine translation. So as you can see, it's in the word, right? Everything is in the word. You know what it means. Machine translation is converting one human language to another. Hindi to English, English to French. So very simple. That's what machine translation is. In fact, the models that we use in machine translation, we're going to be discussing in tomorrow's webinar. That is continuation of this one. So do not miss out on that if you are particularly interested in how this works. One last use case that I'll be discussing here is building chatbots. So everyone has gone through websites where, usually on the bottom left or on the bottom right, there'll be a pop-up, and that pop-up would be like, how may I help you? So that's a chatbot, right? You ask questions and it gives you appropriate responses based on what you asked. So that is what is NLP. That is what is chatbots. You find chatbots on the Play Store. You can find it on the App Store. There are chatbots for friends. You can get a girlfriend chatbot, but I highly recommend you do not do that. But so you're getting what the use case here is, right? So you're getting an understanding of what chatbots do. So all of these which I have discussed, the major core part of its usage is through NLP. Here I listed out some other uses. Here I've just given other uses that exist. And as you might be observing all of these, reading through, you might be getting a understanding of these are all branches of what I have discussed, right? These are all sub use cases of what I had initially discussed. Okay, so we have understood what it does. Let's look at the how part of it. So NLP pipelines, I've given an image here, this chart. So if you're familiar with even a bit of data science, even a bit of machine learning, you might be pretty familiar of the texts that and the images that are here, right? So what is the first part? The first part of any particular project is getting the data, right? Obviously, if you don't have data, there's nothing, you can't do anything. So that's the data acquisition part. Next is the cleaning part and the pre-processing part. So you churn your data, you create it into something meaningful where you can use it later on, which is the feature engineering part or the feature extraction part. And after that, obviously, you have to create your models and you evaluate those models and then you deploy them. So this webinar will be just discussing everything up till evaluation. We won't be discussing the deployment stages of it. That would be covered maybe somewhere you can research on your own. So everything up till evaluation will be discussed here. So the first part is text pre-processing. Now, if you've been attending our previous webinars, you might have seen how pre-processing works. But the pre-processing for NLP is particularly different, right? What do we have in NLP? We have texts, right? The other webinars, when we were performing CNN, we were performing RNN, everything was numbers, vectors, arrays, matrices, right? But we have text, human raw form of language text, right? So the pre-processing steps are a little bit different here, but they're very, very easy to grasp. So let's look at through a few of them. So obviously, pre-processing is done to perform analyze and do predictions for your further on models. So let's look at the steps. First step is tokenization. So tokenization is very, very simple. You basically, all you have to do is split the sentence into words. So you take a particular sentence and you split each word, and those words are known as tokens. So basically the words are split into tokens. That's what is all about tokenization. Next is lowercasing. Very, 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 very easy to grasp what lowercasing is. You convert everything from uppercase to lowercase. But why is it important for NLP? It's very, very important. It's one of the most important things you have to do even in any pre-processing step. It differently, and the words mean differently. So that's why lowercasing is very, very important. So next is stop words removal. Stop words are the commonly used words that occur in the documents. So like and, he, the. So these are the stop words that exist. Sometimes they do not really signify anything, and they do not really mean anything, and hence they are usually, most of the times, they're removed. It totally depends on your model. It totally depends on your project if you want to pursue it, but most of the time none. So let's look at two other steps of pre-processing. First one here is stemming. So Latin for stem means to originate from. So it's just the same here. Stemming is a process of transforming a word to root form. So as you can see on the image on your right here, we have a certain word, we have lots of words, and the root for each word is consult. So every word here can be broken down into consult, right? So that is what stemming is. The stem does not make, sometimes what happens is the stemmed words does not actually make sense.
Gayatri here, sorry to interrupt. Your screen is actually not visible. You lost connection in between, so please share your screen.
Sure, just a second.
Yeah, thank you.
Okay, is it visible now?
Yeah.
Okay, great. I'll just restart from stemming here. I think I must have missed something. So stemming is the process of transforming a word to its root form. So anything, you can see the image on the right here, consult, consultant. So all the root word for all these is consult. Sometimes what happens is the root words for stemming do not make sense in English, right? Sometimes it does not make sense. We're going to be looking at it later on in our hands-on code. So this is one particular disadvantage that usually people face. So if we face this, this is tackled by another process known as lemmatization. So it's very, very similar to stemming, but the only difference is the lemmatization actually reduces your words into words that actually exist in your language. We're talking about English here, so words that will be reduced, that will be rooted, will actually exist in the language. So we've gone through the pre-processing part. They were very easy, as we had seen, very, very easy to grasp. Next is the feature engineering part, or the feature extraction part. So I have an interesting analogy of how feature extraction works. Let's consider the fact that you are making Maggie, right? Everyone loves Maggie. I love Maggie, so I love making Maggie all the time. So let's consider the fact that you make Maggie, and you are first. What do you do while you make Maggie? You boil the water, then you put in the noodles, and then you put in your masala, and then you boil it and you make it and you get Maggie, right? Very, very simple. So what was going on here? What was the intermediate step in between with all our raw things and the final Maggie? We're mixing everything, right? We're mixing all the features, mixing all the data we have. So again, let's come back. We're talking about NLP here. So we have the text, we have data, we convert it into such format that can be used later on for our models. So while we were making Maggie, we were converting, we're taking everything, we're boiling everything and making Maggie, right? So it's the same as what we, same as it happens here. Convert our data into matrices or vectors, which are known as features. And there are numerous ways which we can do that, and we'll be looking through them shortly. So that's how feature extraction works. So here I have given one example of one feature extraction model, that is counting words. So very, very easy to understand. You basically count the number of times each word or each token occurs in a paragraph or a text you have. We'll be looking at this in our hands-on code soon, very soon. And lastly is the modeling part. So we are left with two things, right? Modeling and evaluation. So this is the modeling part. So NLP is all about modeling. Without modeling, there is no NLP. Without NLP, there might be modeling, but we're just talking about NLP here. So what is modeling? You basically train your data, and you can provide it an algorithm that can learn over, and from that you can find out and make predictions about data. So NLP actually, it's very, very vast, like very, very vast. You have lots of models, you have lots of things that exist, right? So in fact, there are pre-trained models that exist, and these pre-trained models are the ones that are trained for on supercomputers, on data that you and me cannot actually work on, because of the fact that we have laptops, we have simple laptops or desktops which we can't work on, and it would take around maybe few hundreds for us to like train it on, right? So there are pre-trained models that actually exist. So enough of the text part of it. Let's get to the code. I am going to be shortly presenting the code here, so give me a moment. So is the code visible to everyone? Can you just give a thumbs up? Just react a thumbs up if you can see it. All right, great. I see many thumbs ups. That's great. Okay, so yeah, let's start with the code. That's what I think everyone is here for, right? So NLP can be performed using numerous libraries, and one library that we are performing here and we're using here is the NLTK library. So NLTK is a free open source library. Any one of us can use it. So obviously, first thing I've done here is pip install NLTK. Obviously, we are running it on Google Colab through Python, right? So I do a pip install NLTK, and after that I import it, and I have this function known as nltk.download. The thing about NLTK is that it's very, very big, right? There are numerous packages that exist in NLTK, and these packages consist of models, these packages consist of corpuses, these consist of texts, lots of databases. So there's lots of stuff in that. So it amounts to approximately 2.5 to 3 GB. That's why you can actually individually download each package you want. So here are the different packages that exist. This is just an example. So for this particular webinar, I've taken one package here known as Gutenberg. So I've just passed it into this NLTK to download Gutenberg, and I've imported it here, and I've printed out the files here. So can you guys let me know in the chat box, what are these text files? Like, if you are even familiar with what are these, can you just write it down in the chat box? Where have you seen these text files? So no one knows. Okay, so these are basically classics, right? These are classics written in the 1600s, 1700s, if no one is aware. So Emma by Jane Austen is a famous book. I recognize Shakespeare here. So these are the famous books that exist from the 1600s and 1700s. So this is one particular corpus, which is a collection of texts. So this is one particular one that known as Gutenberg. Let's explore one of them, right? So let's explore one known as Emma by Jane Austen. So I've called that here in Emma, nltk.corpus.gutenberg.words, and I've stored it into a variable known as Emma, and I've printed it out here. So what is this? What I'm seeing here? I'm seeing a list, and obviously it's a package, so everything's organized. So let us just slice the list here. So I've taken the first 100 words that exist in our text file. And as you can see, it's written Emma by Jane Austen, Volume 1, Chapter 1. So this is Chapter 1. So yeah, this is basically the whole book in the form of a list, right? Let us do some operations on this. Let us see what all stuff exists. So first part is let us look at the number of words, the number of sentences, and the number of characters that exist. You can actually do that using the NLTK module. So as we go through the code, we'll be required to download certain packages. As I said, I mentioned before, you need certain packages one by one that we'll be downloading. So here, for this one, we're using the punct sentence tokenizer. So I've downloaded it here. And here I have used it for finding out the characters, the words, the sentences, and I've stored it here. So after printing it out, I can see like there are approximately 890,000 characters, approximately 192,000 words, and 7,000 sentences, right? So that's a big book. So yeah, that was it. That was all about the NLTK part of it. I'm pretty sure you guys can look through and explore more what NLTK offers. So let us look at the things that we had discussed before, right? We had discussed text preprocessing. So first part is tokenization. As I mentioned, tokenization is basically breaking down sentences into words. So here is where I have I've used nltk.tokenize and I've imported the word tokenize module. So I've taken a sample sentence here and I've put it and passed it into my function word tokenize and stored it in words. I printed out the type, and as you can see, it's a list here, right? So let's print out the list. After printing out the list, I can see that the sentence has broken down into words, or what we call the tokens, right? The words are tokens. So that's how very easy, right? That's how you do the tokenization part of it for getting words. You can also get sentences, right? You can find out sentences from paragraphs, which is very similar. There is another module known as sent tokenize, and I perform the same thing here. I've given an example paragraph here, and I printed out the sentence, printed out the variable that contains all the sentences. So as you can see, the paragraph has been broken down into each 4 sentences, right? So that was it about tokenization. Next part is lowercasing. If you're aware of string parsing, you've performed some string slicing stuff, you'd be aware of this function, string dot lower, right? This is very easy. I'm pretty sure most of you might be knowing it. So I've taken the sample list here, which is sents, and I've looked through each of these sentences, and I've just put parsed dot lower. So as you can see, I get the lower of each sentence here. Another important part of preprocessing is punctuation removal. So punctuations are of little use in NLP, and sometimes they can interfere with our modelings. So most of the time they're removed. So for this, we use another module known as the regex tokenizer. So I have called it here, and I have passed it into this variable known as tokenizer. And I've taken a sample sentence here, and I have printed out the result. So as you can see, the result is vaccine is out. When is college going to reopen? So as you can see, the question marks have been removed, the exclamation marks have been removed. Next is stop words. Stop words, again, these were the words that occur frequently and sometimes do not make sense. So here I have downloaded another package known as nltk.download called stop words. So you download that, and from the nltk.corpus you import it. And here I've just printed out the stop words that exist for the English language. So as you can see here, I, me, myself, he, she, all these are stop words, right? So these are the ones that occur frequently. So what I've done here is I've put it into a list known as stop underscore words. And just to show you, I've taken a sample paragraph here, which is, it's an explanation of what NLP is. So let's look at how stop words are removed. So firstly, I've initialized the punctuation remover variable. I have tokenized it here and stored it into no underscore puncts. And I use the no stop words where here I'm finding out the words in the no puncts list and seeing if it exists in stop words or not. And if they do not, we add it to this particular list. So as you can see, I printed it out here. Natural language processing. So as you can see, is removed, of is removed. So these were the stop words that were removed, right? And here you have the whole particular sentence in the form of tokens, with your stop words removed. Next part is stemming. So often these are the words, as we had discussed earlier, these are the words where your particular word can be broken down and you can get the root word. So in NLTK and in most of the libraries that exist, there are three major algorithms that are used, which are router, snowball, and Lancaster. So one homework for you guys is finding out what is the difference between these three and how differently they work. So you can explore that on your own. So for this, I'm using one particular one, which is voter stemmer, and I have called it from the nltk.stem, and I've instantiated it on a stemmer variable. So I've taken a list with, so let's look at how it's done, right? So I've taken a list with certain words here: trouble, troubling, eat, eating, and these are the words that will be stemmed. So after so I've done it here in this particular line where I have called the stemmer function here, and I've stemmed it for each word that exists in this particular list. So after stemming, I get this. So yeah, so these are the stem words. So if you guys remember, I was talking about sometimes the stemmed words do not make sense. So here is one example. I have stemmed trouble and trouble, and it gives out this. This does not make sense in English. You won't find this in the vocabulary. So this is this is one issue that we face in stemming, where these do not make sense in the end. And as I had mentioned, when they do not make sense, sometimes people use lemmatization. So it's the same thing as stemming, but here the words that are generated are actual words. So sometimes people actually use stemming, sometimes people do not use stemming. Same applies to lemmatization. It's their wish sometimes if they want to perform. It totally depends on the accuracy of the model you want. So I've taken lemmatization here as well. So for demonstration purposes, I've taken, so for this, you need another package known as WordNet. So for almost everything, there is a package in NLTK which you would need to gradually download when you are working through. So here we have WordNet, and I have imported that. I imported a WordNet lemmatizer from nltk.stem and lemmatizer, and I've instantiated it here. So same as stemming, I've just taken some words, I've performed that function here, and I printed it out. So as you can see, rocks comes down to rock, corpora, which is the plural of corpus, comes down to as corpus, goods comes down to as good. So these are the ones, these are the rooted words which actually do make sense. So next one was a feature extraction method known as counting words. So you have seen most of the things that are existing in the text preprocessing part. Let's look at under one feature extraction part, and after this we'll take a short break, and Akshat here will be explaining the rest of the feature extraction parts of it. So here I've taken counting words. So counting words, very, very simple. Basically, you count all the tokens or the words that exist in a particular paragraph or sentence that you have. So here I've taken this sample passage, and counting can be done easily by this library known as collections. And from collections, you import a counter module. And here I've created a function, count words. So what is it doing here? So this counts is equal to dict. So what does this do? This enunciates an empty dictionary which will eventually contain our word and the count of that word. So we'll be going through that later on. So next part is obviously converting it to lowercase, removing the punctuations and tokenizing it, which is being done here. And lastly, finding out the counts of all of the words, which is done using the counter function. And here I've just called out this function, and as you see, it's printed out. He, the, and as you can see, of, close are counted as one time in the paragraph, which, crutch. So yeah, these were the words. And so that's how counting words is done, right? So one thing I missed out here, I missed out something in this function, right? When the processing steps that I discussed, that was stop words. I didn't remove the stop words here. And as you can see, the consequence of not removing stop words, you can find out he, the. So these are the words that occur a lot and they do not make sense, as I discussed earlier. So, and these are occurring a lot, and that's why it's very, very important to remove stop words. So yeah, that's about it for the first half of this particular webinar. And till then, we're going to be having a short break, and we'll have a break for 5 minutes. So after we come back, we're going to be discussing some more topics on feature extraction. So till then, you guys can follow us on our community pages on Instagram and LinkedIn. Get to us on our Twitter, and obviously explore our YouTube videos.
Okay, so here we are for the second session part. Give me a heads up if you can see my screen. Okay, cool. Fine then. We can start. So that was a great session by Rohan Mathur. So for now, we will be moving on to the other parts of NLP pipelines. So what this meme says. So this meme says, what is the importance of pre-processing in the NLP pipeline? So if your text processing goes wrong, then all the modeling part also goes wrong. So you need to be keep thorough about the thing that you're doing. So these things are important in NLP pipelines. So moving on to the next part, that is part of speech tagging. Okay, so remember part of speech tagging from your school, noun, pronouns, verbs, adverbs, etc. Identifying how the words can be used in a sentence, better understand what is being said. It can also point out a relationship between words and recognize cross references. So as you have heard from Rohan, that NLTK package, so it makes us easy for us to it makes us using the POS tag function, which we'll be using in our hands-on session, which returns a tag of identify different part of speech. So you can see the examples in the hands-on session. Okay, moving on to the next topic, that is n-grams. So what's the word only says the what the thing is. So now we got talking about the most widely used machine learning text mining algorithm, which is used in NLP projects. It's an important concept in understanding text analytics. So essentially, n-grams is a set of one or more consecutive sequence of words that occur next to each other. As mentioned above, n is a numerical value that implies that n items of sequence of text. So what's the application? When we type a text in search engine, we can see the probabilistic mode of search engine start predicting the next set of words based on the context. This is also known as autocomplete feature of a search engine. So it's a quite good thing to know that. Okay. So next thing is name entity recognition. So, what it does. So name entities are typically noun phrases that refers to some specific objects or place. Out in the wild performance, it's not always good, but training on large corpus definitely helps. Name entity recognition is often used for index and search news articles on companies or interests. So basically, is used for information extraction or thing. We will be using this in our hands-on session too. And now moving on to the infamous term bag of words in NLP domain. So the feature that we are looking is bag of words. So the bag of words generally treats each document as an unordered collection of bags of words. Okay, so here the document is a unit of text you want to analyze. For instance, if you want to compare essays submitted by student to check for plagiarism, each essay would be a document. And if you want to analyze the sentiment conveyed by tweets, then tweets would be a document. So I think that would be clear of what this document is. Okay. To obtain a bag of words from a raw of text, you need to apply appropriate text mining processing and cleaning that Rohan has said that what we are doing is text processing. In text processing, we have you cleaning and we do normalizing and splitting and stemming and further on. Okay, so then we treat them as a resulting tokens on an unordered collections of set. So the document in your will produce a set of words. Okay, so after this, so keeping as a different sets may lead us to a hard to compare between them. Okay, so if any words occur multiple times, so is there any representation? A more useful approach is to represent words into a vector of number representing how many times number occurs in a document. Okay, so a set of document is also known as corpus. Okay, it's an important term that is being used in NLP, and this gives a context of vectors to be calculated. And first we collect all the unique words in corpus to form our vocabulary, and then arranging these words in some order, let them form a vector position or column of vectors and store them in a frequency a term frequency into a document term matrix. So this is a document term matrix and the term frequency of each words. Okay. So moving on to the next one. So in order to find the similarity between document, a more mathematical way would be to compute the dot product. Okay. So what is this? The dot product of the corresponding elements, as the word says. Okay. And greater the dot product, more similar to the document, the more similar the document is. Okay, the dot product has one flaw. It only captures the portion of overlap, is not affected by others values which are common. So here are different can end up of common and as one, so they are identical. So so this has a flaw that always gives a one for identical values. So what's a better approach? So better approach will be using COSINE similarity. Okay, so that what is it? So it's the dot product of the vector divided by the magnitude of the vector, as you have heard of in the class 10 mathematics. Okay, if you think of this vector as a arrow pointing in some dimensional space, then the theta is the angle between the identical vector has a value equal to 1 if it is orthogonal, equal to 1 if it's as the same angle, and that's 0. And if it is orthogonal, it will be 0, and it will be -1 if it is opposite. So the values ranges from -1 to 1. I think you have understood this well. Okay, let me give a pause if you can read this topic terms. Okay, fine. Moving on to the next topic is the more widely used term in NLP pipeline, that is TF-IDF, that is term frequency inverse document frequency. So what is this? TF-IDF is a statistical measure that evaluates how relevant document, how relevant a word in a document is in a collection of document. Okay, so generally it weighs the importance of word in document. So let me say what the importance of using TF-IDF over bag of words. So flaw in bag of words is it treats every word as a common, whereas intuitively we know that some words occur frequently. For instance, a financial document, cost and price may be pretty formal terms. We can compensate using this by calculating number of occurrence for each word. This is also called a document frequency. So what we do is that we divide it with respective term of frequency. This gives us a metric that is proportional to the frequency of occurrence of the term in a document, but inversely proportional to the number of document it appears in a document. So you will get confused with the terminology that we are using, but if we get to the hands-on session, then you will be clearly get the thing that we are talking about, because the formulas are in the hands-on session. Okay, so it highlights the words more uniquely in a document, and it's better for characterizing. And you may have heard of the TF-IDF transform, or if not, then it's okay. It's similar to the product of weighing vectors that we will be discussing a hands-on session. Okay, so moving on to the more important part of a pipeline, any machine pipeline or any NLP pipeline, is evaluation metrics. Okay, once we have trained the NLP model, we need to evaluate the performance of model. Okay, it is vital to understand that the concept of similarity is highly dependent on the domain and environment of the application. So we can choose the following measures to access the performance. Now, what are the things that we're using in evaluation metrics? There are many metrics, but for this session, we are only focusing on the two metrics, that is COSINE and JACCARD similarity. There are many metrics. You can give a search on Google, because if you want give your own thoughts on this, then you can't learn on your own. So you need to get your hand dirty on this and get too deep into that things. Okay, so getting into the particular topic, that is cosine similarity. So what is cosine similarity? How it is useful? It measures if you want to consider duplicate whenever comparing a textual documents. Okay, the overview is that it computes the cosine angle, as you can see here, cosine angle of between the two documents, and estimate how similar the documents are. To the keynote to is that the similar the document, the angle, the bigger the cosine value, and the more the similar the documents are. Okay, so word can be converted into non-zero vectors by using a number of text mining. algorithm, that is TF-IDF, and bag of words, as instance we have discussed previously in the slides. So the feature of the cosine similarity is the equation will be resulting the value between 0 and 1, as the term frequencies are always positive, as we have discussed that in the term document matrix. Okay, so what is this document? Document and doc2 are the two vectors, and I represent the vector component. And so you can use this in code also. So scikit-learn library has a feature which has a feature as a cosine similarity function, which is helpful for getting the evaluation metrics in an NLP pipeline. Moving on to the next metrics, that is JACCARD similarity, is all about finding the community via the intersection of data. We can compute the JACCARD similarity confidence score. It is computed by the intersection of two sets dividing by the size of the intersection of two inner sets. So you can see the formula, the intersection and the union. So you can also use this similarity by using scikit-learn library using the JACCARD score function. Okay, moving to on the last theoretical session is that summary. Okay, whenever you are getting on the hands-on session, you need to have a summarization of all the things that how the code works. So putting all things together, the NLP pipelines comes handy when convert the text into lowercase and removing the special characters, stemming, limitation, stop words, bringing it all together, text normalizer, modeling, and if it is n-grams, you can apply POS, bag of words, and TF-IDF vectorizing, and for your evaluation metrics, cosine similarity, and JACCARD similarity. So I think I have completed all the theoretical sessions, and now we can move on to the coding part of it. So let's get started. Give a heads up if you can see my screen, or I need to zoom it a bit so that you can see it. Is it visible? The code are visible, or I need to zoom it a bit? Okay, fine. I can start it. Okay, a bit of zoom can be fine. Okay. I feel that it's good to go. Okay. Okay, fine. So as discussed earlier, the theoretical session part of speech tagging, and the code is here. So you need to download the package from NLTK, this particular package, average per subterm tagger for word tagging. So from the NLTK pipeline package, we import the POS tag, and from NLTK tokenizer, we import the word tokenize. I have used a sample sentence. You can see here using the word tokenize function, I passed the sentence and I entered all the POS tags. So what the particular thing is, the CC comprised of coordinating conjunction, and RB is for adverbs, and in is for prepositions, etc. So you can find all the important terminologies that are in the NLTK documentation. Okay, moving on to the next topic, that is n-grams. As we have discussed, is used as a text mining forecasting model. So NLTK package also have this in NLTK utility module. We import n-grams and from the collection of counter. So I have taken the sample text text publication. So using the NLTK tokenizer function, word tokenize, I pass the text and value of the n-grams I need. If I enter 1, I can see a 1 n-gram as an example. If I want 2, and then I can get the 2 n-grams in example. So This was the n-grams, and I feel that it would be easy to understand. Okay, you can code it afterwards the session, and there are many more things that you need to learn. So you have to get your hand dirty on this so that you can learn much more deep into it. So because the name entity recognition is used for information extraction process. Okay, so let me introduce you how the information extraction works. Okay, so here you can see a diagram. So the diagram signifies that raw text string. How the string is then puts in the sentence segmentation, and then we get list of strings when we tokenize, and then after tokenization we apply part-of-speech tagging. After this we get a name entity detection. We get chunk sentence, then we apply the relation detection. After that we get a list of tuples. So the two terms that is important for extractions are the name entity detection, the relation detection. For this code, we will only focus on the name entity detection. But it'd be good if you search about this because it's very high and in the information extraction. So in the code, I have a POS, as you can see, with attached to the particular grammar. So, particular expression for regex, which forms a particular graph that. So dt comes first and then j, and this is a particular expression that is used for getting the parsing all the text from the list. So after we apply the parser, we pass this graph. So you can apply this draw function to get a of the good presentation. But you can download the ticket so that you can get. I hope you will. Now words, so back as we have discussed model. Back presenters are take into length of vector by counting how many times each word appears. This process also quite used in NLP. So import Keras library. You can also make your own by hard coding it, but for a beginner you can import the from the library. Okay, so Keras has this pre-processing text, and we import the tokenizer, docs, and after this I used a tokenizer method to initialize it, and I passed it a fit on text. After this, if I use this text to matrix, I get a matrix of each word representations. And if I use the text, then I can get each word having a clinically identified. Okay. So you know that how TF-IDF is being preferred over back of word. So because it uniquely identifies the word in corpus. So TF-IDF is a weighing system that assigns a weight to each word document based on the term frequency and the reciprocal of the document term frequency. This is the thing I was talking about in the theoretical session. These two important terms. Okay. So this is a formula that we discussed, that product of two term frequency and inverse document frequency, which gives a transform of this. Okay, so using the scikit-learn, we import the TF-IDF vectorizer and data. We took the same data set so that you can get the good idea about it. So same as TF-IDF vectorizer method, I import the fit transform and pass the data from here. And using the pandas, I used to array transform and pass it to the index parameter, and you can see the values of each word. So I feel that you get if I okay. Last thing is overall the pipeline works. Okay. For the I'm using a simple and filter all the features that they use in NLP. Okay, you can download the data set. Okay, fine. If you can hear me. Okay, fine. Okay, so let us talk about the dataset. I used spam filter, and after this, I used the simple read table for importing the datasets. So using head function, you can see the overall first five call.
Yeah, I think Akshat got disconnected. Let's just wait for a while. I think he'll come back.
Is it visible, Rohan?
Yes, yes, yes,
Sorry
yes.
for that. Excuse me for my network issues. Okay, let's move on. Okay, using the head function, you can see the first five rows of your data set, and I can see that label has a two feature, and I using a label encoding using numbers 0 and 1. So it's a very important thing. Encoding is an important feature in NLP or machine learning pipeline, so you should follow it using so label map it to the ham is 0 and spam is 1. Okay, you can see the label has 0 and 1 respectively. Now moving on to the pre-processing. So what we do in pre-processing, generally we get to the get the text into lowercase, and we remove the punctuations and special characters. So here I am doing the same thing. We get the into lowercase, and using the also I remove the punctuations and all the special characters too. Okay. After this, I found out the frequency of each words. It's important to know how the words repeat each itself. Okay, and then uh, using you can use all the things for pre-processing text of. Okay, I feel I'm live. Okay. Okay. Rowan, is it visible or not? Give a heads up. Fine. Okay. Cool.
Yeah, you.
Okay, fine. Then, yeah, I was talking about the count vector function. Though it generally checks the lowercase and the patterns. It checks the punctuation marks that in the text. I'll also remove the stop words that are in the text. So using the Sky guideline, you can import that count vectorizer, and here you can see the count vector function. Using the count vector, you can see the parameters that are there in the text, and using the document, you can check all the text, all the unique words that are in the text. Okay, so I have discussed all the things, and I will go through a bit fast now. Okay, so using transform function, I have imported all the things. You can see the term document frequency is, and now the last part is the
So I think I'll just present. Akshat is having a lot of issues.
Yeah, Rohan.
Yeah.
If you can present, that would be good. Could you move to the test and train split that was talking about?
Yeah, we were here.
Okay, cool. So as you can see that we do the test and train split. So after this, I use the speed processing count vectorizer function, and then from using the fit transform, I input the X train and the transform for the X test. And I'm using the naive based machine learning algorithm for this, but you can use any other classification for all any other machine learning algorithm for the classification problem. It depends on you on how you perceive the problem. Okay, so here's the parameters that I have defined it: alpha equal to zero point 0.1, prior none, and so on. So moving on to the last part, that is the evaluation metrics that are important for judging the how the model performs. There are four terms that are important, and you can go through afterwards. And I have predicted using the text prediction, and you can see that the accuracy score, the precision score, and the recall F1 score. So here it is, the theoretical hands-on session. I was a bit laggy in the last session, but I feel that you will try it out in your after this session so that you can get the good grip of the thing. So now Rohan will be presenting the thing. Thanks, Rohan.
So yeah, before we head on to the quiz, I would like to mention the event that we have tomorrow, the continuation of the NLP series, which would be day 6 and the end of the deep learning webinar series, which is being hosted. And it will be taken by Tarushi and Harsh. And I recommend you all to join it because they'll be explaining some really interesting models and how it will be applied in the use cases that we had used. So after this is the quiz. So we'll be posting the link for the quiz on our Discord server. So the link to the Discord server is in our chat box. You can find it and join the Discord. And the link of the quiz will be shared shortly.
So yeah, hi guys. So I hope you have enjoyed today's session. So the today's quiz link has been posted in our Outer Circle NeuRes channel. So you all are requested to kindly proceed to that channel and attempt the quiz. It is now open now and it will be closed by 6:50. So thank you so much again. And tomorrow we will be having our last day session, which is day 6 for the natural language process. I hope you have enjoyed today's session. And again, if you had any queries and any sort of doubts, please feel free to connect with us on the Outer Circle. Thank you so much. The quiz link has been posted on the channel, so you can take a quiz right now, and it will be closed by 6:50. So yeah, thank you so much.